about all it boils down to is acceleration downwards is always minus 9.8. Basically. Right, let's try this.
Okay, so holding R is vertical.
Yeah, so resolving vertically.
And so A is minus 9.8.
Yep.
S is 1.4.
Mm-hmm.
U is 0.
Yeah.
And T is 2.
Okay. Which will this be?
Will this be S equals UT plus half A squared? And so we do, we just solve for T.
Okay, go on, solve for T with this one. This one is something I want to see. Yeah. S is minus 1.4. You'd probably figure it out anyway. Because we're talking about when it reaches the ground. Like the time it took to reach the ground. So at time is 0, this is S is 1.4. But if you're looking at it the other way, at the time when it reaches there, the S would be minus 1.4. The starting S is 0.
I got 14 root square root of 40 over 7.
Square root of what, sorry? 14 over
14
over 7, like that, is it?
and then over 7.
What is that roughly?
Yeah.
Like, what is that as a decimal?
That is rough. 0.53.
0.5345, great. 0.535. And part B.
And so now, that's we're looking for V now, aren't we?
Yeah.
So V is V. S is minus 9.8.
A is minus 9.8.
Sorry. A is minus 9.8. S is minus 1.4. And shall I put T as an exact value?
I'd use U equals 0 maybe.
Yeah, and U.
Because we know that for certain.
And then we do S equals to
No.
U plus V over 2.
Oh.
Oh no, so that's wrong, my bad. It should be, no, so that's wrong. It should be S equals to...
No.
V squared equals to U squared plus 2AS.
Yeah.
Yeah. And so now I'll just do the next one. And shall I give it as a simplified again?
Yeah, what is it? 3 sig fig.
Yeah. 5.24.
meters per second. 5.24. Yep. Yeah. So we were square rooting. So you'd have to make sure the negatives are the right way around. Same with part B. Minus 9.8, minus 1.4. Just watch out for that. You'd probably just make it positive. Okay. How about this one?
Okay, so I think we're doing R as vertical,
Mm-hmm.
and I think we're saying that S is 7,
Yeah, so that's above the ground.
U is 21, or no, it's V21.
I think it's U. Yeah, it's projected with that speed.
Is A 9.8
Which direction?
upwards?
And so if you fall down, you fall to space.
Oh, will A be 0?
No, A is minus 9.8.
Is it always minus 9.8?
Well, we're resolving upwards, and so A is pulling down, and so it's minus.
Okay.
If we were resolving in this direction, then that would be positive, and these would be negative, and all the formulae would still work out.
I think I may have got something wrong. I said S is 7, but it says here the greatest height above the ground reached by the ball.
Hold on. A ball is projected from a point which is 7 above the ground.
Yeah.
I think it'll work. Yeah,
Okay.
I think it'll work.
And should I? So I can either now have V or T to add in.
What is V?
Is V21?
No, hang on. S is S because we're trying to find S.
Yeah.
What is V?
21.
The final velocity. So you throw a ball up, reaches its maximum, goes back down. What was its velocity at its highest point? So that's its initial velocity, like, shoots up 21, slows down, reaches its maximum, comes back down. What's its velocity at its maximum height?
0.
Correct. And that's something that comes up a lot.
Yeah. So, is this going to be a V squared equals U squared plus 2AS?
Yeah, so V squared 2AS. That's it.
I got 45/2.
Was it as a decimal? 22.5?
Yeah.
Okay, I think there's a little trick though. And so from its starting point,
going to be we have to minus 7, don't we?
I think you would add 7 because this is 7, like here.
Okay. Yep.
And that's 22.5. And so greatest height?
29.5.
Yeah. Above the ground. Yeah. Okay. And any idea about B?
So we know that S is 29.5.
What does it mean by time of flight of the ball?
How long the ball's in the air for?
Yep. And so if you do S is 29.5, that would get from starting point to the top point.
It needs to be 22.5, doesn't it?
You could do that. Let me think. Balls.
Why just not use S? Should I just use U, A, and B?
I'm not sure. So I'll look at it this way. So this is 7 above the ground. And the ball is kind of like that. So we have to find the total time of flight for this ball. What I would do is consider here, what the values will be here. So what 3 things do we know about this point?
Is that when it hits the ground?
Yep.
So V is 0.
V is 0 up here. V is definitely not 0 down there. It'll hit it with some speed.
A is minus 9.8.
Okay, so we always know that.
Is U21?
Correct. U is 21 because that was the initial for that journey.
Yeah. So is S going to be 22.5?
I believe. So let's see. This here is 22.5.
Yep.
What is this S here?
That's 29.5.
I believe this S here, compare it to the starting point, because that's what you're doing, time from the start till the end.
So 29.5.
It's 29.5 from the highest to the lowest.
So that's just 7.
Yeah, and we're resolving upwards.
Minus 7.
Yeah, because we took acceleration to be negative and upward speed to be positive. Yep, and we want time.
So it's used to, yeah. And so we now do x equals ut plus half at squared.
Yep.
And so that would be I got as well, so 4.60. 4 point 60. 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 4
And so t equals 4.60 seconds. Was there a second answer?
Yeah, but it was negative.
Any idea what that's about?
No.
It's for pure maths. See the graph?
Yeah.
If it went that way, that would be the second point at which s is -7.
Okay.
But time in the real world won't be negative. Let's see. So that was 29.5. Excuse me. That was 4.6 seconds. Okay. Stuff that comes up all the time. At the greatest height, v is 0. So it's like shot up with a speed of 21 meters per second. It's slowing down, slowing down, slowing down. Hits its greatest height. It's like the gradient is 0. Final velocity at its greatest height is 0. And then it starts going back the other way. The other thing is you have to compare the start of the journey to the end of the journey. So start of the journey, u is 21. A is constantly minus 9.8. But s is -7. So comparing the start of the journey to the end of the journey. If you did s as 22.5, that would give you the time it took from the start to the top point.
Okay.
For s to go back to being 22.5. So that's how these things work. Let me see. Yeah, let me just see something. I think I've done these as well as they can be done. Okay, let's try this one.
So are we doing R as vertical again?
Mm-hmm.
And we're saying that U is U. And then S is 62.5. A is minus 9.8.
Mm-hmm.
V is 0.
Very good.
And then we just do V squared equals to U squared plus 2AS.
Let me see. Plus 2AS. I think it'd be fine for that.
Yeah.
And part B.
So I'm guessing here we're going to make S 50.
Okay.
We're also going to do V 0.
No. V is 0 at the very top of the end point.
So A is minus 9.8.
So A is minus 9.8. Hang on. So U is 35. That's from part A.
Okay. And then we just do T as 2.
Yep.
And we do S equals to U2 plus half AT squared.
Yeah, so work this one out.
two answers.
What'd you get?
1.97 and 5.17.
Say it again.
And 5.17.
Okay. We want the time that this particle was above 50 meters.
So we know that above 50 meters. So I'm assuming will it be 1.97?
This is what the journey looks like. You said S is 50. That's there. So that's time, that's displacement. That's after 1.97 seconds, S is 50. Then on the way back down, at 5.17 seconds, S is 50 again. We want the time that the particle is above 50 meters.
So is it 5.17 minus 1.97?
Correct.
And so that would be 3.2.
And it might be, if it rounded correctly, 3.2 seconds. Great. Yeah. And so visualizing it, the journey helps. If we want when it's above a certain amount, get when it's equal to it, and then you can just find the difference. And that'll tell you how long it was above it for. Other than that, you're good. 1 second. Gotta do it. All right. How about this?
So R is vertical, I think. S is 63.
I'm not so sure. It might be. This question. Ball falls vertically from rest. Let me just. Okay. So it's 63 high. So that up there is 63. You have some ball that falls. So that's A. This thing. Then another ball is projected up. The two of them collide somewhere. Find a distance where the balls collide. Okay. Let's go with S is 63.
And so sorry, do we need to separate it because we've got two balls here?
I think we'll have to have two. It might be simultaneous equations. Let's just write down 3 things we know, 1 thing we need. Now I see, find the distance where the balls collide. So let's just say S equals S. Anything else we know?
Are we going to say A is minus 9.8?
So A is minus 9.8, definitely.
Are we going to say V is 0?
It's definitely not 0. When they fall, when they hit into each other, they're both moving.
Is it going to be U? Oh no.
Oh, yes.
Is it going to be U is 21? First. So is it minus 21?
We're looking at ball A, I believe.
0.
Yes. So let's just clarify. So this is ball A. S, A, U. Ah, there's a trick. There might be a trick. Maybe there's not. When this is falling, when this hits into this one and this hits into this one, they should have two different V's. Like, it would just be a coincidence that they have the same velocity. However, from the start of B's journey to when it hits and the start of A's journey to when it hits, the time would be the same for both. And so if we do T is T, then that will allow us to swap into the other one. So what equation would we use for this one?
Pardon, sorry?
And so what equation would we use for these?
We're going to use S equals UT plus half AT squared.
Half AT squared. Okay, so S, so that bit is 0, equals minus 4.9 T squared. So we have two unknowns. We could do something similar with B to get a second equation. However, I think we can get something even simpler. What would be this distance plus this distance?
63.
And so we called this one S. I'll just keep calling it S. So S plus S2 equals 63. And so how can we use that?
Is S1 equals to S2?
Not necessarily. That'd be a coincidence, I believe.
So do we need to say something like, oh, do we need to do S is equals to 63 minus S2?
That's what I'm thinking. 63 minus S2 or something. Okay. And so this second journey, hang on, does that really help? So how about the second journey? If we were to make an equation for the second journey. Yes, hang on. So the second journey, S is 63 minus S. T is the same T. A is minus 9.8. And what else?
U is 0.
U is not 0 for ball B.
Oh, U is 21.
Yeah. And now let's try this one.
And so now we do S equals UT equals half AT squared.
Yep. So what do you get there?
So when I'm subbing that in, we've got do I need to put S, like, do I just put 63 minus S instead of where S is supposed to be?
Yeah. That's what we have to do.
Sorry, I'm confused because we've got like 2 unknowns and I don't know what it is.
We have 2 unknowns. We also have 2 equations. That's equation 1. That's equation 2.
And so we put S in ahead of minus 4.92 squared.
Yep.
So we're then left with 63 minus S equals 21T minus S. Or even plus S.
Let's see. You see this? I think this might be the easiest way.
Yeah. And so we do 63 plus 4.9T squared
Mm-hmm.
is equal to 21T minus 4.9T squared.
Yep.
And we then make this equal to 0, and so we can do minus 9.6T squared plus 21T minus 63.
9.8.
9.8, sorry.
Yeah. Okay, what do you get for that one?
It says it's got no real roots.
Dagnabbit. This question continues to confound me. Where did we go wrong? So, this is S. This is called S1. S is, so U is 0, T is T, A is minus 9.8. That's white. That's white. For the second journey. Nope. Okay, so S is minus 4.9 T squared. Okay. And we know S plus this second S gives us 63. So another way of saying this S is 63 minus the second distance. Yeah, so for the other one, S is 63 minus S. T is the same. U is 21. That should work. 63 minus s is equal to 21t 63. Where did I go wrong? So, well, okay, this is make it simpler. Don't know if this will work. We said like this is S2 and this is other one up here is S1. Yeah?
Yeah.
We said those two, when you add them together, you get 63. And so, simultaneous equation style, add those two, and you should get 63.
Is this like... So now... And then for 21t, am I just adding nothing and getting 21t?
Are we just getting the same equation though? 21t, it's the exact same equation. For the first one, u is 0. Wait, a is positive 9.8. Why are they doing that? S1 is 4.9 t squared. For the first one. Let's see. That's why. It's just a minus sign. It's because for this first one, if it starts from here and it ends here, it's gotten negative. So it should be like minus s. That's why. And so it's that s is plus 4.9 t squared. Okay. So when you add the two, the t squareds cancel out. That's right. It was just a minus sign because it's going down, so it's negative. All right. 63 equals 21t. What is t?
T is 3.
And so we didn't want t though. We wanted s. And we wanted s from the bottom.
So are we just subbing in 3?
Yeah.
So are we doing 21 times 3 minus 4.9 times 3 squared?
Yep.
I got 18.9.
18.9 meters. 18.9. There we go. It was just a minus sign. That's all it was. It went down. So s, instead of s equals s, it's like s equals minus s. With simultaneous equations. All right. Any questions about this one?
No.
Right. Let's try these exam questions.
Okay, so R is vertical. U is U. T is 2.
Mm-hmm.
Is v a third u?
Yep. That's 3. We need 4.
Yeah. A is minus 9.8.
Yeah. And it's quite common to always seem like you don't have enough information with these ones.
So are we now going to v equals u plus a2?
Yep.
And so a third u is equals to u plus minus 9.8 times 2.
Mm-hmm.
And so we can just do,
It's nice to have a normal type of question.
I got 147 over 5.
29.4.
29.4.
Great. B.
So are we going to do t is t?
Yep.
And a is a minus 9.8.
Yep.
Is v 0?
V is 0 up here.
Yeah.
That would be like half the journey.
Is v is u 29.4?
Yep. And there's something. So any idea how you deal with this one?
I don't think so.
What if we did v is 0? What type of time would that give us? How would we get the full journey?
So v being 0, does that give us half the journey?
Correct. And so what would you do at the end?
Double the answer.
Correct. Let me now tell you something that might help. At the beginning, u is 29.4. Just by looking at it, I know what v is going to be. Any idea? At the end, so from here it's like 29.4 up to 0. going the other way, it'll be 0 to minus 29.4. And that way you can get the full journey in one go. Instead of doing v as 0 and then doubling your answer, you can do v as the negative of u. V is minus u, essentially.
Okay.
Yep, remember that one?
So do we just now do v equals u plus a2?
Yep.
Sorry, did we just say that v is u minus 29.4?
V is minus 29.4.
Yeah. And so are we going to do minus 29.4 equals to 29.4 plus minus 9.8 times 2?
Yep.
And so that will give us... I got 6.
I like answers like that. Let's see, 6 seconds. I just want to see how they did it. Oh, they did crazy stuff. Okay, S is 0. That's another way you could do it. S is 0, and then they'd get 2 answers. Time is 0, or time is whatever this one is. Yeah, okay, great. Any questions about this one?
No.
So I should put this question before the simultaneous equations one. Let's see this. Alright, this is going to be weird. Yeah, this is like simultaneous equations one.
So... Okay. I think again it's just going to be R is vertical. U is minus 5. A is minus 9.8. S is 46. I don't think it collides with the ball, doesn't it?
Yeah, collide with the other one, so we don't know S.
Do we need to do what we did again when we did like S1 plus S2 is equals to 46?
Yeah, so S1 plus S2 equals 46. Let me see. And so any idea what else we could do here?
Do we just say S is equals to S2 minus 46? Plus.
What I'm thinking is from where it started to where it went, S is minus S1. And that's what we missed the last time. We said like S is S. What we should have done was S is minus S1. We're resolving upwards and it fell down.
Okay.
And so that's S1. And so from its starting point to there, that's like minus whatever that distance is. And what else? How else did we deal with it?
we said S. So we said S is 63. We do the same thing and say S is 43 or whatever it was minus S2. Or
Sure, but that's still only three things.
and say S is equal to UT plus half AT squared.
So in that case, T. You haven't said T yet. There's an important reason. Why do we choose T? It's because they have two different U's. So you've got U1, U2. They've got two different V's, V1, V2. Two different S's, S1, S2. A is constant. That's good. However, the time from the bottom to the collision point and from the other ball, the top to the collision point, will be the same. Both journeys end at the same time. And so that's a good thing because it's the same for both of them. Okay, what's next?
We now do S is equal to UT plus half AT squared.
T squared, yep.
And we're now going to say, so minus S1 is equals to minus 5t loss a half times minus 9.8 times t squared. Oh no, yeah, times t squared.
So let's do that. Okay.
Should we do something like, and then say S1 is then equals of minus of that, and then sub it into S1 plus S2 equals 46.
I think we have to do the same stuff, but now with ball B, because if you sub it in, there's no time. There's no time in this in the second equation.
So we're now going to solve for ball B, and R is vertical again, etc.
Yeah.
And so and then A is 18.
No.
Oh, sorry, U is 18. No, that's sorry. A is minus 9.8. T is 2. S is S.
Yeah, I'm just gonna say S is S2.
Yeah.
Because these two distances won't be the same.
And I think we're using the same equation.
Yeah. So S2 UT minus 4.9 T squared. Yep.
And then so we now have 18. Do we now need to change S minus S1 to S1?
Yep. So what would the first equation become?
It would become minus 1 times minus 5t minus 4.9t squared.
Sure. Basically, all the minuses turn to plus.
Yeah. And so we now have to add both of those together and make it equals to 46.
Yep.
And so I just put that into my calculator and I'm doing.
What are you putting into your calculator?
I was So we're just going to put everything in, then make it equal to 46, and then solve for 2.
What is everything?
So everything is 46 is equals to 23, 2.
Okay.
I think that's just doing it.
Yeah, that is just it. Yeah. That's
And
it.
so T 2.
So t equals 2 seconds. Full marks.
They said they want the distance.
Mm-hmm.
And so now we're going to sub in 2 into one of the t's, I'm assuming. Oh no, this is the point where A and B can't be the point where A is. So for where R is vertical for A, do we then sub in 2 for T there, and then S is S, and then yeah.
Which equation? 1 or 2?
The first one.
Well done.
Yeah. And so now, what are we going to do? I'll just go into my calculator.
Mm-hmm. Okay, that's it.
So sorry, I accidentally put. So do I need to put in T is 2, don't I?
Yep.
Yeah.
I'm just guessing my answer.
It's minus 148 over 5.
SD?
So it's probably going to be so minus 29.6.
Uh,
29.6, right?
yeah, so we changed all the pluses for that thing. 29.6, great. So we figured this stuff out. I think this was the hardest part of the whole thing. That is minus S because it goes down, whereas this one is positive S2 because it goes up. Yep, you have time is time for both of them, and so that allows you to get one thing that's the same, and then yeah, S1 plus S2 is 46. All right, any or many questions about that?
No.
So that's, I think, as difficult as it's gonna get. Let's see. Hey, okay, got it. And so what do you give yourself for that stuff?
I think at the end maybe it's 6. Yeah.
Well, that's that chapter done anyway. So next time we do mechanics, we can do chapter 10 if you want from year 1 or something else.
Yeah, just chapter 10, please.
Okay, and next lesson, stats.
Yes, please. Yeah.
Okay. Any questions for me in general?
No, I don't think so.
All right. Well done, Andrey. You're doing great. I look forward to talking again next time.
Should we see you on Friday?
All right. Take care. Goodbye.